as we start this lesson on Intro to Derivatives, I did just want to remind you about the difference quotient that we talked about a few lessons ago. So just to recall, to determine the slope of a tangent line at the point x, f at x, we consider a nearby point x plus h, f at x plus h, and we want that point to be as close as possible to the point in question, and compare the slope of this secant at that point. This is the old method that we've previously talked about, but basically we're going to be using the slope of the secant to approximate the slope of the tangent. Now that we've talked about and worked with limits, we can now say the closer h gets to 0, the closer the slope of the secant line is to the slope of the tangent line. So in other words, the slope of the tangent line is equal to the limit h approaches 0 of f at x plus h minus f at x divided by h. This is just really your instantaneous rate of change. Now we're able to come to the conclusion that we have our definition for the first principles. So the first principles definition of a derivative says that the derivative of the function f of x is equal to, now here we have some new terminology. So this is said as f prime of x, or the first derivative of f of x, and that is equal to the limit as h approaches 0 of f at x plus h minus f at x divided by h. This first example says, find the derivative of the function f of x equals x squared. So just your basic quadratic function. The first thing that we need to do is start off by writing our first principles definition of a derivative. So f prime of x is equal to the limit as h approaches 0 of f at x plus h minus f at x all divided by h. Now that we have that definition, we're ready to start subbing in. You want to make sure that you continuously write the limit as h approaches 0 until the point where you plug that in. So the limit is h approaches 0 of x plus h squared minus 8x squared all divided by h. I'm going to continue to expand and simplify this. So the limit as h approaches 0, x plus h squared will give me x squared plus 2xh plus h squared minus x squared divided by h. I can see right away that I'm going to have an x squared minus an x squared canceling out, and I'm going to be left with the limit as h approaches 0 of 2xh plus h squared divided by h. Now I can see that all of my terms do have h in them, so I can factor an h out, and I'm going to be left with the limit as h approaches 0 of 2x plus h. Now I am ready to plug in or substitute in my h of 0. So when I do that, I am going to be left with 2x. This means that the derivative of f of x, or the derivative of x squared, is equal to 2x. In this next example, they're asking us to find the derivative of a quadratic, so f of x equals x plus 2 squared at a specific point, so at x equals 2. What we're doing is we're finding the slope of the tangent at a specific point. Remembering to keep our notation, we have f prime of x is equal to the limit as h approaches 0 of x plus h plus 2 squared minus x plus 2 squared all divided by h. We're going to continue on simplifying. So the limit as h approaches 0, x plus h plus 2 times x plus h plus 2. Now, if you want to do all of that in one line, go ahead, more power to you. I am just going to do it separately. X plus 2 squared, I am going to do this now. So x squared plus 4x plus 4, all divided by h. So the limit as h approaches 0. So foiling this out, I'm going to have x squared plus xh plus 2x plus xh plus h squared plus 2h plus 2x plus 2h plus 4. This is really bad notation and I'm really sorry. Minus x squared, remember we're bringing this negative through, minus 4x minus 4, all divided by h. I'm going to go ahead and simplify the numerator of this. So what I can see right away is that I have an x squared and a minus x squared. I have a plus 4 and a minus 4. I have a 2x and a 2x, so that's 4x minus 4x. I have, what am I left with here? So what I'm left with is the limit as h approaches 0 of xh and xh, so 2xh plus an h squared plus a 2h and a 2h, so a 4h, all divided by h. Now I can go ahead and I can factor in h out of the numerator and the denominator. So I'm going to be left with 2x plus h plus 4. At this point, I am able over 1, or you don't have to write that step. At this point, I can go ahead and plug my h equals 0 in, and I am going to be left with 2x plus 4. I'm having to go ahead and switch slides just because I'm running out of room, but what we found on the last slide was that f prime of x is equal to 2x plus 4. So what this is telling us is that the slope of the tangent of our original function is 2x plus 4. If you remember, the question was asking us to find it at x equals 2. So what we're going to do is we're going to say that f prime of 2 is equal to 2 times 2 plus 4, 4 plus 4, which is equal to 8. To summarize this, what this question is telling us is that the slope of the tangent at x equals 2 is 8.